Okay, tomorrow's your test, 1.2 to 1.6, all right? Anything that we have gone over is fair game. I'm going to try and pinpoint some things that are more important than others, that sort of thing. I'll change some problems around to make them a little easier for you to understand. But in this first section, this is from 1.2. All you're doing to test if it's a function represented algebraically is to say yes or no. You can tell it just by looking. What are the two things that y in an equation cannot be in order for it to be a function? In absolute value or an even power, okay? So the only thing that matters, the first two test questions tomorrow are what? What's the only thing that matters? What letter is the only thing that matters? The y. Okay, so if I look at this first one, y is the only thing that matters. The two restrictions are y raised to an even power or y in absolute value. So is 35 a function? No. What about 37? Yes. What about 39? Yes. What about 41? No. Questions about that? The only two things that matter, y raised to an even power, y in absolute value. If we have a graph and it says, is this a function, yes or no, use the vertical line test, literally draw a vertical line. If it only touches the graph one time, what's your answer? Yes, it's a function. If you draw the vertical line and it touches more than once, what's your answer? No, it's not. Okay? That's simple. If I'm scooting down here, we do odd, even, and neither, guys. Algebraically, there is a test question that says prove algebraically. If you guess right and you put even and you don't have any work to back it up, I'm giving you 0 points. You have to show algebraically. How did I tell you guys to do this algebraically? Opposite numbers. Okay, you can plug in x if you want and negative x, but it's easier to see if you use opposite numbers. 2 and negative 2, 3 and negative 3. If you think the function is even and you plug in a number and it's opposite and the answers come out to be the same, then yes, it's even. If you think it's odd and that you plug in a number and it's opposite and they come out as opposite answers, 2 and negative 2, 7, negative 7, then it's odd. If neither of those things happen, then it's neither. So if I look at 79, I have a clue of what I'm testing for. Do you think this function could possibly be even or odd? 79. Why?
Because it's 2 and even power.
Yep, because it's squared. So if I try 2 and negative 2. All right, I'm going to plug in negative 2 and I'm plugging positive 2 for 79. So I have negative 2 squared plus 6, and over here, 2 squared plus 6. Agreed? Negative 2 squared is 4, and 4 plus 6 is 10. On the right-hand side, I have 4 plus 6 is 10. The actual answer value doesn't matter. The relationship between the two of them does, though. Those are the same numbers, so you just proved to me that 79 is what kind of a function? Even. Good. But I got to see your work. 81, what do you think it could be? Okay, you think it could be even because, again, it's squared. So for 81, what do you guys want to do? 2, negative 2? Okay. You can do negative 2 and 2 every time. It's fine. So you have negative 2 squared minus 8, and that's squared. And you have 2 squared minus 8 squared. Negative 2 squared is 4. So 4 minus 8 squared. What's 4 minus 8? And negative 4 squared is 16. So over here, 2 squared is 4. 4 minus 8 is? Negative 4 squared is? What do you notice about these two numbers? They are the same. So 81 is what kind of a function? Even. Good. Yes, ma'am. What do you think 80 could be? Odd or neither. Why is it odd and not even like the other ones? Because it's raised to an odd power. So again, use any number you want. 2, negative 2 will work every time. So we have 2x squared plus 6x minus 1. 2x squared plus 6. Yeah, you're right. I'm sorry. Minus 1. So negative 2, positive 2. So you have 2, negative 2 cubed plus 6 times negative 2 minus 1. What is negative 2 cubed? So I have 2 times negative 8 minus 12 minus 1. Agreed? What's 2 times negative 8? Good. Negative 16 minus 12 minus 1 is? Negative 29. Good. So now over here, I'm going to do the exact same thing, but I have 2 times 2 cubed plus 6 times 2 minus 1. Well, 2 cubed is 8, right? 8 times 2 is 16 plus 12 minus 1. What's 16 plus 12? 28 minus 1 is 27. Okay, what do you notice about these two numbers that I can't write? Right? They're not the same. They're not exact opposites. They're what? Neither. So you just proved to me that 80 is neither. You will have one of those on your test, so just make sure you understand what they're asking and how to do it. You'll have a question like this. I will give you your graph on an actual coordinate plane so you can count real easy. But you're gonna have a picture and it's gonna say, write the equation. Well, you have to know what function family you're talking about. You have to understand where to write the numbers, your plus and minus 2 and all that stuff, shrinks and stretches, in order to identify and correctly write the equation. If I look at number 89, what function family is this? Quadratic, okay? This is our x squared. This is our quadratic. From the original, right? This is what our original quadratic looks like. What did our black graph do? Okay? We'll say right 2, up 1. If you said it was up 2 and whatever, I need you, on the test, you'll be able to count. This is a little harder, I understand that. But you need to understand that it shifted horizontally to the right, vertically up. So how would I write this? What would my equation be? F of x equals what? Parentheses. Where does my squared go? Where does the minus 2 go? Good. Very good. So x minus 2 plus 1. Very important. If you have a horizontal shift left and right, you need to be inside the parentheses, opposite of what you think. Vertical shifts up and down are going to be outside. All right, look at the second one. What family is this? Absolute value. Absolute value makes the V. Absolute value. And where did my absolute value graph move? Up 3. Okay, so f of x, g of x, p of x, I don't care. But how do you write the equation that says my absolute value graph moved up 3? Absolute value of x plus 3. If I had the plus 3 inside my absolute value bars, what would you be telling me? To the left. That went left 3. Good. So just make sure you guys have those correct. All right? Okay, up here, you're just evaluating. You're just plugging in, guys. They're just saying, evaluate, simplify. So what do they want me to plug in? For letter A, what do they want me to plug into the equation? 1. So you have x squared plus 1. If I plug in 1, 1 squared plus 1 is 2. For B, what do they want me to plug in? Negative 3. So I have x squared plus 1. So I'm literally putting in negative 3 plus 1. What's negative 3 squared? And 9 plus 1 is 10. Good. I'm going to use x for C because my B's look like 6's. So for C, they want me to take x cubed and plug it in for the x. So it's x squared plus 1. So I'm going to say x cubed squared plus 1. If you raise a power to a power, multiply. So it's what? X to the 6 plus 1. Good. Again, yours is a B. And then in D, what do they want me to plug in? Okay, so x minus 1 squared plus 1. What does x minus 1 quantity squared mean? Well, yep. You're going to write it twice. So x minus 1 times x minus 1. And then you got your plus 1 at the end. X times x is x squared. X times negative 1. Negative 1 times x. Good. Negative times a negative is a positive 1. And then you still have that extra 1 at the end. So combine like terms. X squared, what? Minus 2x plus 2. Awesome. We okay? All right, you will definitely, most definitely see evaluating piecewise like this. Guys, these are easy questions, but they're easy to mess up. So make sure that you are paying attention to what you're doing. They're going to give you, they meaning me, are going to give you numbers to evaluate. Right here, hold on one sec, Franco. Right here, your parameters are what tells you, it's how you figure out which expression to use. Franco, question.
Will there be any like drawing piecewise function?
Mm-hmm. Yeah, we'll do it in a second. But guys, in letter A, they say, evaluate this piecewise where x is negative 2. Which inequality does negative 2 fall? Is negative 2 less than or equal to negative 1? Or is negative 2 greater than negative 1? It's less than or equal to. So you would show me, you would say, okay, for this one, I'm going to use the top expression. That's how you're showing me your work. And then you can say, I'm going to plug in negative 2 for x. So 2 times negative 2 plus 1. What's 2 times negative 2? Negative 4 plus 1 is? Negative 3. That's it. You'll be surprised. A lot of you will make a silly mistake. You'll tell me that that's negative 5 or something just silly. But if I don't see any work at all, I cannot give you any points. So try to show me as much brain power that's going on in there so I can try and give you some points. Look at B. Which expression am I going to use for B? Where does negative 1 fall? Less than or equal to. Good. Negative 1, I'm going to use the top expression. So I have 2x plus 1. So 2 times negative 1 plus 1. Negative 2 plus 1 is? Negative 1. You guys okay? Okay. In C, I'm going to use 0. Well, which expression am I going to use? The top one or the bottom one? Bottom one, because 0 is greater than negative 1. So x squared plus 2. 0 squared plus 2. What's my answer? 2. And then which am I using for D? 2. Is 2 greater than negative 1, or is it less than or equal to? It's greater than. So I'm going to use the bottom expression again. X squared plus 2. So 2 squared plus 2. 4 plus 2 is 6. Questions on that? No? Okay. All right. The domain ones, guys. I'm going to change these problems a little bit. I'm going to explain. Some of you were having some questions yesterday. This is from section 1.2. It's like the 4th or 5th slide, but it tells you the 3 restrictions. Everything for any function, you can plug in all real numbers. Anything, negative infinity, positive infinity, except if there is a variable in the denominator, if there is a radical, or if there is a radical that is in the denominator. So if you have a variable in the denominator, you have to figure out what x cannot be. If you have a radical, you have to figure out what x cannot be. If you have a radical in the denominator, you have to figure out what x cannot be. So in like 47, what is the only number in the world that x cannot be? Negative 2, right? Why can it not be negative 2? What happens if it's negative 2? The denominator equals 0. So you could tell me all real numbers except x can't be negative 2. It can be any number in the world except for negative 2.
We can't just write down x cannot equal negative 2.
You can, that's fine. But if I go to something like this, okay, a bunch of you had questions yesterday. I'm going to do this 2 different ways. My numerator doesn't matter. X squared, it could be anything you want. I have a problem because there is a variable in the denominator. Yes? So we would solve this and we would say, okay, x squared plus 1 cannot be 0. So I would subtract 1 from both sides. X squared equals negative 1. Then what do? I'd take the square root. What happens when I take the square root of a negative number? Becomes imaginary. We're talking about real numbers here. So in this case, are there any domain restrictions? No. Because the only domain restriction, when you solve it, it becomes imaginary. So this would be all real numbers. But if this problem were like this, all right, let's just change it slightly. Why can't I erase? Okay, change this to x squared minus 1. Let's pretend this says x squared minus 1. Again, got a variable in the denominator. We can't have it. So you would say x squared minus 1 cannot be 0. Add 1 to both sides, yes? So x squared equals 1. Take the square root. What are my domain restrictions now?
X can't be 1.
What kind of 1? Plus or minus. Because if it's positive 1 and you square it, it's 1, then 1 minus 1 is 0. If it's negative 1 and you square it, it's 1, 1 minus 1 is 0. So make sure that you guys, if there's a variable in the denominator, it's not underneath the radical or anything, you just have to figure out what x cannot be. If you have something like this, and I'm going to change this one to make it a little more like what we're going to see. This is just a radical. Is this a radical in the denominator? No, it's just a radical. So this answer has to be what? Greater than or equal to 0. Can it be 0? Yes. Can you take the square root of 0? Absolutely. If this was in the denominator, would it be greater than or equal to, or just greater than? Just greater than. So just make sure you guys are seeing that. So if I square both sides here, I get x minus 16 greater than 0. So in this case, x has to be what? To 16. If you have a radical, you'll have some sort of inequality. It's going to be a range. It's got to be bigger than something. If you have just an expression like before, like these other ones, then you're going to have like specific values that x can't be. All right, let's do a piecewise. Every single version of every single test, every single class, mine and Miss Prez's, you will all have piecewise functions. They won't be the same, but you all have piecewise functions. Just treat it like two independent lines and work from there. If I look at my first line, 3x plus 5. In 3x plus 5, what is my slope? 3 over 1. And what's the y-intercept? So I'm going to graph this. I'm going to go up to 5, point, and then I'm going to go down 3 over 1. Why did I go this direction? Why is my line going in that direction? Because it's positive. Now, this is what makes our piecewise unique. Where do I look? What values do I care about on this red line? X is less than 0. Guys, this is where x is less than 0. A lot of people yesterday were asking me, oh, so you always divide it on the y-axis. We're not looking at the y-axis. We're looking at where x is less than 0. On the left-hand side or the right-hand side, where x is less than 0. On the left-hand side. So I want everything over here, and I do what with everything else? Erase it, okay? Another thing you have to make sure of, what kind of a dot should I have at 5? Why is it open? Because it's not equal to. Make sure, I'm going to check that, guys. Make sure you're paying attention, please. Please, 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 please. So it's an open circle. Now my other line is x minus 4. So what's my slope for x minus 4? 1 over 1. And where's the y-intercept? So go down to negative 4. 1, 2, 3, yeah. And my line's going to be like this. Where am I looking? Where do I care about the values? Where x is greater than 0. Is that the right-hand side or the left-hand side? Right-hand side. And what kind of a dot do I have there? Closed. Okay, there's your piecewise. Just do them each separately, and then it's not bad. When we have our combinations of functions, you guys, everybody's going to have a bunch of different kinds of combinations. If you're plugging in a number, what should you get as your answer? A number. If you're plugging in x, you should get x. So guys, watch. If I do 107, I'll do them all down here. 107 is telling me to do what with the two functions and plug in what number? You're subtracting and plugging in 4. You can subtract the functions first and plug in 4 in your simplified, or you can just plug in 4 from the beginning. If my f function is 3 minus 2x minus, what are we doing, f and g? Square root of x. So they want me to plug in 4. So I'm just going to say, okay, 3 minus 2 times 4 minus the square root of 4. 2 times 4 is 8. So 3 minus 8 is negative 5 minus, what's the square root of 4? What's my answer? That's it. Don't complicate it. If there's a number, just plug it in. In 109, what do they ask me to do? Add the exact same functions, right? So you have 3 minus 2x plus square root of x. What number do they want me to plug in? 25. So you have 3 minus 2 times 25 plus the square root of 25. Yeah.
For 107 and 109, are we supposed to be doing plus and minus 2? Like, so we have 2 answers then? No?
Because you're not physically taking the square root, it's already there, so you're just assuming it's the positive. So guys, what's 2 times 25? Okay, so what's 3 minus 50? Negative 47 plus, what's the square root of 25? What is negative 47 plus 5? Negative 42. Good. What do they ask me to do in 111? Multiply. So take the f function, which is 3 minus 2x, and h, what, 3x squared plus 2? What number do they want me to plug in? 1. So you have 3 minus 2 times 1, and then 3 times 1 squared plus 2. What's 2 times 1? Right, negative 2. So 3 minus 2 is 1. And then you have 1 squared is 1 times 3 is 3. What's 3 plus 2? So what's your answer? That's it. Now, you're going to have to be careful with negatives, that sort of thing. But when you have a number to plug in, it's fairly simple. When you have these compositions, I told you to work from the inside out. In 113, what are they telling you to do?
To plug in 5 to the function of g and then plug that answer into the function of f.
Correct. You're going to take the 5 and plug it into the g function. So g is square root of x, yes? So when I plug in 5, I get square root of 5, correct? So now you take that answer, the square root of 5, and you plug it in to the h. So my h function is 3x squared plus 2. So 3x squared plus 2. So I have 3 times square root of 5 squared plus 2. What happens when you square a square root? It goes away. So you just have 3 times 5 plus 2. What's 3 times 5? And 15 plus 2 is? That's it. For 115, what are they telling you to do? So you're going to take the h function and plug it into the f. So if my h function, write down what f is. F is 3 minus 2x. Yes? All right. And h of x is 3x squared plus 2. So they are literally telling me to take this whole function and plug it in right there. So it's 3 minus 2 times 3x squared plus 2. So I have, what's negative 2 times 3x squared? Negative 6x squared. What's negative 2 times 2? Negative 4. Combine like terms.
Negative 6x squared minus 1.
Yep. Be careful, guys. Very easy to say negative 6x squared plus 7 or minus 7, something like that. Just pay attention. The sign that's in front of the term goes with it. Just don't make silly mistakes. We okay? All right. Guys, go to the next one. I will go over. I had to screenshot the graphs that were at the beginning of your review. They're at the end. We'll talk about it in a second. But I want to go through. You guys will absolutely have to identify from equations parent functions and transformations. So in 97, what parent function is 97? Quadratic, cubic, linear. What is it? It's rational. Very good. And what does this minus 6 mean? Down 6. It's our vertical shift, down 6. You can literally tell me like that. What's 99? How do you know it's cubic? Because there's the thirds to the third power. It's cubic. So tell me what all the transformations are. Right 2. And which way? Up 5. Good. That should be, these should be easy questions. What family is 101? Square root. How do you know it's a square root? Because there's a square root. It's literally that easy. What's this negative in the front mean? Good. Reflect over x. You got to tell me which way. What does this plus 6 mean? Perfect. What family is this? 103. Absolute value. Good. What does that mean? Perfect.
What lesson is that from?
1-4, I think, yeah. All right, this is what your questions on the test will look like. You won't have to guess. But think about what family you're talking about here. Think about everything that happens. What is it?
Yeah.
Absolute value. It's our absolute value, okay? That means absolute value of x. So think about our parent function for absolute value just goes right through the origin, points up. How is the purple graph different? Negative out in front. It's a reflection over x, right? What else did the purple graph do? Well, which way did it move? Left 2, right? And what else? Up 3. So you have to write an equation that represents an absolute value graph that reflects over the x, moves left 2, moves up 3. Where you place things is very important. So we're going to have f of x, g of x, p of x, I don't care. What does my equation look like? Negative, good, Ely, out in front, good. Plus 2, opposite of what you think, good.
And then, how many
Plus 3. Make sure my horizontal shifts left and right are inside, either inside parentheses, inside absolute value, underneath square root, and your vertical shifts up and down are in the back. What family is this? What is it? It's not the rational one. It's the square root one. All right, your normal parent function looks something like that. So what did this square root graph do? Where'd it go? It went right 1 and down 3. So we write our g of x. How do I say my square root went right 1 and down 3?
So square root x minus 1 and then outside minus 3.
Very important that you differentiate what's inside and what's outside. If you need to do this, that's fine. But make sure I don't have to guess if you have something underneath the square root that shouldn't be, or if it's outside. And you know, I need to make sure that you understand. You guys need to make sure I can see that. Everybody get that? Yes, sir.
If we go like y equals, is that wrong?
I'd rather you write it as a function. If you could try and remember that, I would appreciate that, but it's not a major, huge deal. Okay, if we're going to find inverses, how do you find the inverses of stuff? Algebraically, what do we do? First thing, switch x and y. So in 125, I have x equals 6y. Now what? Divide by 6. So I would write f negative 1 of x. You have to write that. I'm taking points off if you don't. But that's the inverse notation. So f negative 1 would be x over 6. You could also write that as 1/6 times x. That's fine. But algebraically, you have to switch x and y, solve for the new y, write the inverse function notation. So for 127, you have x equals 1/2 y plus 3. What's the inverse? What do I do?
You have to put the negative.
Okay, but let's solve for y first.
Oh.
So
Subtract 3.
and then divide by
So x minus 3 equals 1/2 y. And then do what? Multiply both sides by 2. So f negative 1 of x is what?
2x minus 6.
There you go. And from 128, I have x equals square root of y minus 6 over 4. Solve. What do I do?
You multiply by
On both sides. So you have 4x equals the square root of y minus 6.
square.
Okay. Square both sides.
Get rid of the root.
Okay. The root goes away.
And then add the 6.
What does that become?
4x squared equals
Does
y
it?
minus 6
Is it 4x squared? 16. Good. 16x squared
equals y minus 6.
equals y minus 6. Now what?
Add the 6.
Add 6. So f negative 1 of x is 16x squared plus 6. All of your algebra rules apply, so just make sure you guys are on top of that. All right, let's go down to our difference quotient. Everything will work out the exact same way. I'm going to do the bottom one, and then I'll do the top one when I'm done with the video. I'll just do it so you guys can see it, but it'll be on there. But what this is saying is it's saying you're going to evaluate x squared minus 3x plus 1 2 times, and you're going to subtract. So you literally are going to take this expression and plug it in for x in the first. So I'm going to do like a big bracket so you guys can see. I'm going to rewrite, instead of x, 9 plus h. How many times? Twice. Then I have minus 3 times 9 plus h plus 1. You guys see that? Everybody understand what I just did there? Okay, then I have a big minus sign in the middle. And now I'm going to do the exact same thing. Now I'm going to do the exact same thing, but instead of the 9 plus h, I'm just going to substitute in a number. So again, here's another big bracket. I have 9 squared minus 3 times 9 plus 1. All of this is over h. You don't have to rewrite the h every time. Just make sure you have it at the end. But does anybody have any questions about what I just did there? Okay, so let's go through and simplify. If I FOIL this out, what's 9 times 9? 81. What's 9 times h?
9h.
What's h times 9?
9h.
And then what's h times h?
H squared.
What's negative 3 times 9?
27.
What's negative 3 times h?
3h.
And then I have plus 1? Minus. Let's do red. What's 9 squared?
81.
Minus
Negative 27.
plus 1. Okay, again, this is all over h. Oh, this should work out, guys, every single time like this. I want you to notice something. Does anybody notice anything? Anything jump out at you like, oh, wait a second. What do I have here? 81. What do I have here?
Oh, you're gonna cancel.
What do I have here?
Yeah.
What do I have here? What do I have here? What do I have here? Every single time, if you do this correctly, all of your constants should cross out. If they don't, then you did something wrong. But if I simplify this in the red, what's 81 minus 27? 64? 81 minus 27? 64? Just say yes. Okay, plus 1 is?
is what's missing.
Yeah, 54.
54. My bad. Thank you. Okay, so in red, over here, I have minus 54. So let's simplify in blue. Well, what's 81 minus 27?
54.
Plus 1. So this should be 53. Sorry.
Oh, yeah. No, wait.
Yeah.
It'd be 50.
55. I'm sorry. I'm tired. 54 plus 1 is 55. So this is 55 over here. And when I have 81 minus 27 plus 1, what does that equal? We just did it, guys. What does it equal? 55. What I'm trying to show you is every time you work these out, the constants will always cancel out. So the only thing you're left with, what's 9h plus 9h? 18h minus 3h. How much?
15.
So 15h plus h squared. And remember, this is all over h.
So it's 15.
So simplify. You're going to take out an h. H plus 15, right? H's cancel out, and then you set that equal to 0. So h 15. Every single time, if you do it correctly, when you simplify, your constants will cancel out.
Isn't it?
I meant to put, yeah. Every single time. What's going to happen every single time?
They're all gonna
Your constant should cancel out. Make sure that you do your math correctly. Okay? Minus 27 plus 1. All right. I want to talk about intervals of increase and decrease after we do this real quick, and then we'll be done. I know this was long. I appreciate. Write down some notes. If a function is even, what are the two things graphically that we need to remember? Symmetric to y, and what about the arrows? Same direction. We'll say same direction. If a function is odd, what do we need to remember? Symmetric to origin, so it goes through the origin. And what do you know about the ends? Opposite directions. Every single test version will have a question like this. Please don't get this one wrong. Two things you got to look at: symmetry and the ends of the graph. Look at the ends of this graph. Are they in the same direction or opposite? Opposite. So if it's odd, what else has to happen? Got to go through the origin. Is this odd, even, or neither? It's odd. Good. Look at this. Look at the ends. What's going on in the ends? Same. So then it has to be what to the y-axis? Symmetric. Pretend I drew this absolutely perfectly. Is this symmetric to the y? Yeah, so it's what? Even. And then lastly, look at the ends. Same direction, but not symmetric, so it's neither. All right, last thing I want to talk about is intervals of increase, decrease. And then we're done. All right, let's. Okay, if I asked you the domain and range of this lovely thing I just drew. Domain and range. You're going to have to do this on your test to make sure you're paying attention to what you're doing. Domain and range is x and y values, yes? So, yes, we're going to do that 1 second. I'm going to do this 2 different ways because there's different versions of the test. But the first way I'm going to do this is, do you guys see that there are specific starting and stopping points on this graph? Okay, so my domain, what are the x values that are used on this graph? -2 to +4. You would write that as -2 with a bracket, +4 with a bracket, because both dots are closed. Your range is from bottom to top. What's the lowest value on the y? -3. And what's the highest value on the y? So your range would be from -3 to 1. You guys see that? Okay, so now if we're talking about intervals of increase, decrease, and constant, what axis do we look at for intervals of increase, decrease, and constant? The x. So from where to where am I increasing?
From 3 to 4.
From 3 to 4. We use parentheses. Do you guys see that? From 3 to 4 on the x-axis. Where am I decreasing? Between -2 and +1. -2, +1. Only look at the x-axis. What did I tell you to do to the y? Cross it out. Pretend it's not even there. Where is my interval of constant?
1 to 3.
From 1 to 3. It is that easy if you pay attention to the x-axis. If you don't, you guys are going to get all confused. Some versions of the test will have arrows at the end of the graph. That changes your answers for domain and range. If I have arrows, what's the domain when I have arrows?
You have to use parentheses. Oh no, all real numbers.
All real numbers, or you can write -infinity to +infinity. Anything. That graph's getting wider, 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 wider. What's the range when I have arrows for this one?
Isn't it?
-infinity to -3.
Right.
Start from the bottom up. What's the lowest point on this graph?
So -3.
So it's -3. It includes it, and it goes all the way up to what? +infinity. Very good. We still look at the x-axis for increase, decrease, constant, but it's a little different when we have arrows. If I have increase, decrease, and constant, where is this graph increasing?
From 3 to
3 to infinity. Good. It's going on forever since there's arrows. Where is it decreasing?
From -infinity to 1.
Perfect. -infinity to 1. Right here. And constant's the what? The same. Good. Good. We okay? It's a lot, I know. But you guys will be all right. The video's long, I know. But I will put up some extra difference quotient practice. I have some problems that we did last year that are all worked out. I'll put them up so you guys can practice that a little bit more if you want to. And then the answers are there so you can check it. But if you have any last minute questions, come see me in the morning. Not at 7:52, like preferably before 7:45, but I will be here. So if you have questions, come ask me. Sound good? You okay? All right.